Hello everyone, welcome to this session. I will still discussing about the simple cell. So far in our previous video, we're discussing about the various defects of the simple cell. So today, let's move on to this subtopic that is the leclanche cell. This is the other kind of a simple cell. It is the cell that uses an aqueous solution of ammonium chloride, that is the solar ammoniac, as the electrolyte. The amalgamated zinc rod as cathode. So this is the recurrential cell. So this is what is made up. It's made up of the uh, this aqua solution of the ammonium chloride as the electrolyte and the amalgamated zinc rod as the cathode. Now the carbon rod as the anode is the one that is fixed in the porous pot containing a powdered mixture of the carbon and the manganese oxide. The carbon, the one that makes the mixture more conducting, and the manganese oxide is the one that acts as the depolarizer. We talked about the depolarizers in our previous video when we were talking about the various defects of the simple cell. Now, this is the diagram of this recurrential cell. As you can see, these are the various parts that are labeled. There's a zinc rod, a ceramic solution that we mentioned before in our notes. Then there is carbon plate, there's polar spot, and then manganese dioxide and the powdered carbon. So these are the components of the recurrential cell. Moving on, let's discuss about the dry cell. The dry cell is simply the cell that is modified recurrential cell, in which the main electrolyte is the paste of the starch and the ammonium chloride. The action of the cell is similar to that of the wet recurrential cell. The paste is the one that is prevented from drying by sealing the top of the cell with some insulating materials. Now, this type of cell, it gives a larger current and a shorter recovery, that is the demoralizing time, than the wet type. Now, hence, this kind of a cell is useful for the greater variety of the applications. However, the local action cannot be eliminated completely in this kind of cells, so that the cells have a storage or a shelf life ranging from a few months to up to several years if stored in a cool place. The local cell is called a primary cell, and this type of cell currently this type of cell current is produced from non-recoverable or irreversible chemical reaction. And here we have the diagram of this, the dry cell, the various components of the dry cell. As you can see, there's a positive pole and a negative pole. There's insulating cap, the insulating coating. Then there's zinc anode, there's ammonium chloride electrolyte, there's manganese dioxide and graphite cathode. An example, when all the zinc has been dissolved in the sickle cell, it can never be recovered to its original form by passing a current through the cell in the opposite direction. When this is just an addition of what we discussed before the previous note. Let's talk about the secondary cell. So the secondary cell, this is the cell which can be recharged after it has been used or it has run down. It is done by passing a direct current from a dynamo or a similar device through the cell in the opposite direction to that in which the cell usually supplies current in an external circuit. Also, the one that is called the storage cells or the accumulator. This is secondary cell. Some of the common accumulators are lead acid accumulators, nickel cadmium accumulators, alkaline and chlorine chloride accumulators. So these are just the common accumulators. The main advantage of this kind of cell or this type of cell that it has a very low internal resistance, and it can therefore give a large current with a little drop in the terminal potential difference. So that's all I have for this session. I hope that's all clear. We discussed about the recurrential cell. Then we've seen the dry cell with the diagrams. Then we've moved on to the secondary cells. We've seen the introduction to the secondary cells. We'll further discuss about the secondary cells in our next video. I hope that's all clear, and thank you.